Hello everyone, thank you for being here today. Welcome to our presentation for subject MAT123 Foundation of Geometry. We are from 2 Square Group and we were excited to share more about application of geometry in real life.
Let me introduce our team. Firstly, our leader Adini Sofia. Secondly, Intan Halia Suhana. Thirdly, it's me, Nur Ain. And last but not least, Jasmine Insalina Disabella.
Our group has chosen 2 cases to demonstrate the application of geometry in real life. As you can see, Biloxi Lighthouse and Queen Piece of Chess.
Our group chose Biloxi Lighthouse as our big scale and Queen Piece of Chess as our small scale for our cases. Both of these have shape combination of cylinder and hemisphere. This example highlight how geometry is applied in both architectural structure and everyday objects.
What is lighthouse? Lighthouse is a tall structure typically located along coastlines, island, or dangerous navigation area, designed to guard ship and warn mariner for potential hazards such as speed, low, or shallow water. They use powerful light and in early times, fire to ensure safe navigation, particularly at night or during poor visibility. Story about lighthouse. First, Edson Lighthouse. The earliest lighthouse were simply violins on hilltop or platform to guard sailors. The Palace of Alexandria, located in Egypt, is one of the 7 wonders of the ancient world and considered the first monumental lighthouse. It stood about 100 meters tall and used mirror to reflect sunlight during the day and fire at the night. Medieval period. During Middle Age, lighthouse construction slowed as trade declined. Monks and local authorities often maintained smaller beacons. Third, Renaissance and early modern era. With the revival of maritime trade in the 15th and 16th century, more lighthouses were built. Advances to technology lead to better lighthouse systems such as oil lamp and parabolic reflector. Fourth, Industrial Revolution in 18th until 19th century. The invention of the Fresnel lens in 1822 revolutionized lighthouse technology. This lens concentrated and magnifies light, allowing beam to travel farther. Lighthouses began to be constructed using iron or steel, making them more durable. Fifth, modern era. By 23rd century, automation replaced lighthouse keeper with a remote control system. Electric light and solar power system become common, making lighthouse more efficient.
Hi, so now we're going to move to the calculation. First, I will do the calculation for lighthouse. Calculation for lighthouse is divided by 2 parts, which is the main body and the top part. So the shape of main body is cylinder, while the shape of top part is a combination of cylinder and hemisphere. Okay, so first thing first, I'm going to calculate the surface area for the lighthouse. For the main body, it is a cylinder with 2 bases. So we're going to use the formula of 2 pi r times h plus r. H stands for height, while r stands for radius. Based on the information that we had gathered, we got height of the cylinder is 19.5072 and radius is 2.286. So we're going to insert this info into the formula. So 2 pi times 2.286 times h 19.5072 plus 2.286. We will get 313.0236 m squared. So next, we're going to calculate the surface area for the top part. So for the top part, we need to add the cylinder without base and hemisphere. So the formula is 2 pi r h plus 3 pi r squared. So based on the information that we had gathered, we know that the height for the top part is 1.8288 and the radius is 1.0668. So we're going to insert this into our formula. So it's going to be 2 pi times 1.0668 times 1.8288 plus 3 pi 1.068x squared. So we're going to get 22.9843 m squared. Okay, so now we're going to calculate the total area of lighthouse. We need to add the answer that we got from above. So the total area is 313.0236 plus 22.9843. We're going to get 336.0079 m squared. So now we're going to calculate the volume of the lighthouse. So first we're going to calculate the volume of the main body, which is cylinder. We're going to use the formula pi r square h. So as we know earlier that the height of cylinder is 19.5072 and the radius is 2.286. So insert this into our formula. So it's going to be pi 2.286 square times 19.5072. So we're going to get 320.25060 m cube. Next, we're going to calculate the top part of the lighthouse. We need to add the volume of cylinder and hemisphere. So the formula is going to be pi r square h plus 2 per 3 pi r cube. The height for the top part is 1.8288 and the radius is 1.0668. So insert this into our formula. We're gonna get pi times 1.0668 square times 0.8288 plus 2 over 3 pi times 1.0668 cube. We're gonna get 9.0813 m cube. So now for the last part, we're going to calculate the total volume of the lighthouse. So we need to add the value that we just got earlier. So total volume is 320.2506 plus 9.0813. So we're going to get 329.3373 m cube. That's all from me.
What is chess? Chess is a two-player strategy board game that involves skill, planning, and tactical thinking. Playing on an 8x8 square board with a 64 square of alternating color, the objective is to checkmate the opponent king. Chess is one of the oldest and the most popular game in the world. History about chess. First, origin. Chess originated in India around the 16th century during the Gupta Empire was known as Chaturanga. Second, spread to Persia. The game spread to Persia and was called Shatranj. Persian influences introduced terms like Shah is the king and mat defeated which become checkmate. Third, introduction to Europe. Chess reached Europe to the trade and conquest by the Arab and Moor during the 8th until 9th century. Fourth, modern chess. Standardized rules were adopted and chess competition. Chess clock were introduced in the late 19th century to counter time during matches. Fifth, chess in digital era. Computer chess program emerged in the 23rd century, culminating in IBM Deep Blue defeating world champion Garry Kasparov in 1997. Online chess platforms such as chess.com and WeChess have popularized the game globally. General information about chess. First, objective. The goal of chess is to checkmate the opponent king, meaning it is placed under attack with no way to escape. Second, chess board and pieces. The board has 64 squares arranged in an 8x8 grid. Each player starts with 60 pieces. 1 king, 1 queen, 2 rooks, 2 bishop, 2 knight, and 8 pawn.
Hi, now we are moving to calculation of queen piece of chess. If we take a look at this piece, there are 3 parts on queen piece. The top of queen piece, the top body of queen piece, and the body of queen piece. For this piece, we use hemisphere as the shape of the top part and cylinder as the body parts. Before we get into our calculation, we had gathered all the information about this piece. So, the total height for this piece is 8.5 centimeter. Diameter of the piece's base should measure 40 to 50% of its height. Since the percentage is in between 40 to 50, I decided to take the middle value of the percentage, which is 45%. So to find diameter, 45 over 100 times 8.5 equals to 3.825 centimeters. And that's for the diameter. To find radius, the diameter we have to divide by 2. Then we have 1.9125 centimeters. All of this is for the body part. Then the height of the top part of this face is generally around 20 to 30% of the total height. So for the height of top part, I take 25% times the total height, which is 8.5, and we get 2.125 centimeter. The diameter of the top part is 1.271. Then to find the radius, we divide by 2. Then we have 0.6375 centimeter. And this is for the top part. Now we can start to calculate the body of queen piece. Since we already know the total height and the height of the top part, we can find the height of the body part by subtracting total height, which is 8.5, and the height of the top part, 2.125. Then we get 6.375 centimeters. The radius is 1.9125 centimeters. For this case, we have to use formula of point base. The formula is 2 pi r h plus pi r squared. Then we enter all the values. R straight is 1.9125. And we get 88.0966 centimeters squared for the area. To find volume, the formula is pi r squared h. Then enter all the values. And you get 73.2542 centimeter per cube. So the next part is the top body of queen piece. The height of it is 2.125 minus width 0.6375, which is the height of hemisphere, and it equals to 1.4875 centimeters. The radius is 0.6375 centimeter. So to find the area, we use the same formula, which is 2 pi r h plus pi r squared. We enter all the value. Pi r squared and then we got 7.2350 centimeter squared. And that's for the area. To find the volume, we use pi r squared h. We enter the value. And then we got 1.8992 for the volume. The last part of the calculation is the top of queen piece. So we know that hemisphere, the height of it is the same with the radius. So the height is 0.6375, which is the same with the radius 0.6375. So the area of hemisphere is 3 pi r squared. We enter the values. And then we got 3.8303 centimeter squared. To find volume, we use formula 2 over 3 pi r cubed. Enter the values. And then we got 0.5426 centimeter cubed.
So, in conclusion, to sum up, geometry is super important in our everyday life. We see it in building, widgets, art, and even in technology. It helps us design things, solve problems, and make our surrounding more organized and creative. By learning about geometry, we can better understand how the world works and how to use it to improve the things around us. And that's all for us. Thank you.